All right, in this video, we are going to talk about a very important topic moving forward, and that is the differences in the ways that data of primitive type is stored versus the way that data of reference type is stored. Okay, so this has to do with how things are stored in memory, and it's really important to understand this moving forward. We will talk about it here when we're talking about objects, and then we'll talk about it again at another point. Okay, so first thing to remember is that in Java, data falls into two categories of types: the 8 primitive types and the reference types. Okay, so an important piece of terminology is that a reference is a memory address. Okay, so when you are creating an object, you know that you use the new keyword, right? So what that actually does is it returns a reference, a memory address where the object is stored, okay? And that's actually what is stored in the variable, okay? When you create an object, the value stored, oops, this is a big old typo in here, but it should say primitive types are stored as values, right? So just cross that out. Primitive types. When you create a variable of a primitive type, it is stored by value. When you create a reference type, it is stored by reference. In other words, the memory address where that thing is located is where it is from. And so I'll have some state diagrams in the following slides here. All right, so primitive types are stored as values. When you have a program and you execute the following statement, int num equals 17, in memory, right, you're going to get like a memory location, which I just visualize as a box, okay? That box is going to have a number that the computer uses to number it, right? And then you're going to have a label associated with that. That's the name that you give to it. And the computer knows, oh, when the user says num or the programmer says num, they're talking about this box right here. Inside that box is going to be the number 17. All right, that's not totally accurate, right? It's stored 17 as a binary number inside there, but you can just think about it as the actual number 17 is stored in there. All right, so that is the situation for primitive types. That's what's called, it's stored by value. All right, the actual number is inside the memory location. All right, so now when you create an object, all right, like a contact object that we talked about before, what happens, right? So here's the statement. If I create a contact object, I am going to get a variable named contact1, and you can see that over here on this box over here on the left. So this is some memory address, right? A reference. And here I've got the label contact1. Inside that box, when you're first doing this, you kind of think, okay, it should be this stuff, right? That's stored inside that memory address, but it is not, okay? In fact, what is inside there is a reference, all right? And that is a memory address. And if you go out to that other memory address, so you can see these numbers match right here, then you will find that information. And of course, this is an oversimplification, but I just want to get the point across about the differences in which the way primitive types are stored versus reference types. So looking at this, when I first learned this, my reaction was, why would you do it like that? This way makes a lot more sense than this does, okay? But when the designers of Java were making this programming language, in this case with an int, they know exactly how much memory that's going to take up, right? We talked about that in chapter 2. It's not something that we really memorized, but they know exactly how much memory is going to be needed to store an int value up front. With these reference types, right? Nobody, the people in Java, the designers of Java, they have really, they can't look into the future and see these reference types that everybody else is going to make in the future. They could be huge. They could take up tons of memory when they do that. And so this doing it this way saves some overhead. They don't know how big these objects are going to get. So instead of storing them as values like we did before, they store them as references. And what that's going to do is going to save some time. Like when you need to copy things, it's going to save that time copying. It's going to save memory by doing it that way. Okay, so this is to manage memory overhead in the future. Okay, to cut down on that. All right. So and that's a good thing. But it has some consequences that you've got to be aware of. If you aren't aware of these consequences, there's going to be strange things happening in your program, and you won't know why. Okay, so we're going to take a look at the first thing we're going to look at is copying objects versus copying variables that are of primitive type. So let's take a look at this primitive copy. All right. Oops. I need to fix that. There's that spurious 3 right there. Okay. So here's what happens. I create a variable called A. It's a primitive type, right? It's an int. And then right here, you can see I copy the value of A to B. All right, and then I print those out, and you can see that's this line right here. All right, next up, I change the value of A to 15, and I print both of the variables again. So you can see A is 15, B is 3. No, there's absolutely no issue. That works exactly the way you think it's going to work. All right, then I change B. All right, so I change the value of B to -10. You can see, okay, B changes to -10. A is still 15. Again, no issue whatsoever. That seems very straightforward, cut and dry. So if I copy a variable right here, if I make this copy, then it still just kind of works out exactly the way that you think it should. Okay, let's take a look at what that looks like in memory. All right, when I get this set up in memory, when I do int A equals 3, I get a variable A, which you can see up here. It has a 3 in it. And then I create another variable B, so I get a completely separate variable over here. And then it looks at the value in A and it copies it to B. So in memory, I've got this situation here. I've got two memory boxes. You can see their memory addresses are different places. All right. Next up, then I do A equals 15. So it just goes into this box and changes the 3 in that box to a 15. You can see it has no effect on this variable down here. B is still 3, and we saw that in the program when we printed it out. Next up, I do B equals -10. So the Java goes down here to the variable B. It says, okay, it's in this location in memory. It goes and puts a -10 in that box, and that's the situation that we've got. Okay, so again, just completely straightforward. Everything works exactly as you think it should. Okay, so now that's the situation for primitive types. It is different for reference types, okay? And so the key here is that when you copy a variable of reference type, okay, remember that's any of the other types besides the 8 primitive types, the information in the object does not get copied. It only copies the reference, which is a memory address, okay? It only copies that memory address. So to you, when you're working through that, you might think like it's exactly like the primitive case in which I have two variables that are completely separate and changing one doesn't change the other. It is not like that for reference types. Changing a copy will change the original and vice versa. All right. So this is where the weirdness comes in, but it's really only weird if you don't if you haven't seen this and don't understand how this works. Okay. All right. So let's take a look at reference copy. All right. So this reference copy, I basically do the same kind of things that I do in the primitive copy. I just do them with objects. These are now reference types, right? These are not any of the 8 primitive types. So I create a new person object, and the person object is very simple. It just has one field with a name and then a get and set method for a constructor and a set method and a toString. That's it. Okay. So I create a person object called Alice, and that's an A, and then I copy that to B. Okay. And then I print out the objects. All right, and so here you can see this is where I'm at. Okay. So I have 2 objects, A and B. They both have the value Alice in the name field. All right, and so now here I change the value of A's name. I use the set method to change A's name to Charlie. And notice there is absolutely no change to B here. I don't explicitly change it at all, right? Only A. And then I print out A and B again. And you can see not only is A's name changed to Charlie, B's name is changed to Charlie as well. So changing the original changed the copy. Okay. So that is totally unexpected behavior if you think that these reference types behave the same way as the primitive types. All right, next up I change B's name to Daniels. Okay. And then I print these things out again. Again, I am only changing B. I'm not messing with A, but you can see that not only is B's name changed to Daniels, then A's name is changed to Daniels as well. Okay? So changing the copy changed the original. All right? And this shouldn't say unchanged. It should say changed, right? All right. So that is strange behavior. You can see that that is definitely not working the same as it was for the primitive types. Okay? So let's take a look at what the reason is. It's this reason right here. Only the reference is copied, not the object itself. All right, so here is how this goes. I create a person object named A. So that's going to set up a variable A at some memory location 2342. Inside that memory location is not the value of Alice, but it is another memory address, a reference. So if you go to that memory address, you'll find the string Alice over in there. Okay. And then when I did the copy, I say, hey, create a new variable B of type person, and take and copy the value for A in there. But it doesn't copy the value, and that's the trick. It will set up a different variable B, and it will set it up at a different memory location. But you can see the issue, right, is that it has the same reference there, that same address. So even though these are two different variables, right, they have the same address over here. So you really do not get two separate variables like you did, okay? And that's the issue. Now, when I do a.setName Charlie, it goes to A, right? It says, looks in and says, well, this is stored in box 1135. It goes there, and it changes the name to Charlie. And then I ask, hey, what is B's name? And I forgot to put the B right here. When I say, hey, print out B's name, it goes, okay, B's is in 1135. It goes here, and it prints Charlie for both of those. All right. Next up, I set B's name to Daniel. So it goes down here and says, oh, that information is stored in box 1135. It goes over there. It changes the name to Daniels. So B's name is now Daniels. And then when I ask, hey, what is A's name? It goes, well, A is stored in box 1135. It goes over here and says, well, A's name is Daniels. So you can see when you copy an object, it does not copy the actual object itself. It only copies this reference right here, the memory address. And again, the reason why it does that is because it saves overhead. Instead of creating a whole new copy, they don't know how big this is going to be. In our example, it's pretty small, right? Size, there's not a lot of information contained in there, but the designers of Java don't know, they can't look into the future and see how big these objects are going to get. That could be huge, okay? And so just to save overhead, instead of making a whole separate copy, they just copy the reference here. And it's a good thing that they did that, right? Because otherwise things would start getting bogged down very quickly. So this is not, even though this seems strange when you first learn about it, it's not it's not really a bad thing. You just have to be aware of it. And it's actually a good thing. You have to be aware of it so you know what's going on, because if you're not, you're going to see all these strange things happening and not realize what the situation is. Okay? All right, so that's a really, if you're going on in computer science and programming, you really have to get that idea stuck in your head about that difference. All right, that's it for this one.